their own definition of large assemblies, and things have changed over the years in terms of complexity, in terms of working with different CADs, in terms of the size of the assemblies. So there's a lot of things that have changed over the years that have made large assemblies a prime topic. So we thought that we would share some information with you today. And as Michel was putting this information together, as he will share with you, there was just too much to put into one session. So we will have to break this in two. Michel will start today, and we will have to schedule a new one, date to be determined. Then everyone who's registered for this will definitely get an invitation for the next one, and hopefully you can join us or watch the recording afterwards. So few notes before we get started with this topic. On your webinar or GoToWebinar window on the right-hand side of your screen, there's a few things. So there's some handouts that are available. And as SOLIDWORKS improves and continues to add to what capabilities are available and tools are available to help manage large assemblies, there's a few things that are new every year, and you'll see some of those in the handouts that are there. Right below that is chat, and it says type message here in a box. If you have questions along the way, please don't hesitate and type them in there. And Michel will either try to get to them at the end if there's time permits, or he will know exactly who typed them in, and we'll get back to you individually. So please, if you've got questions, don't hesitate to put them in there. And again, we're going to split this into two, so we'll start. There's a lot of information to share. So without taking any more of the time today, I will pass this over to Michel, who has been with SOLIDWORKS for over 13 years. He has seen the complexity change in the software and has seen what SOLIDWORKS has done to help our customers along the way, and he will start sharing some of that with you today. So with that, over to you, Michel.
All right, well, thank you, and welcome everyone to this session. Like Joelle said, there's a lot of content. Joelle and I are looking for good topics for these sessions. I said, hey, we could do a session on large assembly, and when I was building the session, I was like, there's just too much stuff. Let's split it out in two separate sessions. So what we're going to talk about when we talk about large assembly. So let's just jump in. First of all, this is the whole presentation altogether. So in the course of those two sessions, we're going to talk about, first of all, defining a large assembly, look at the activities that's happening when you open and update a large assembly, how we can improve file open times, how we can improve update times for assemblies, how we can improve drawing update times, and we're going to finish off with hardware. Now, today, like Joelle mentioned, there's a lot of content. So today, I'm going to filter that down to the first 3 bullet items. So let's start with the first one, which is what is a large assembly. So let's talk about putting a definition around a large assembly. First of all, what is large? What is defined as being large? My definition of being large is not with number of parts or sub-assemblies, is not with the size of the assembly. It's actually fairly simple. How we define a complex or a large assembly is an assembly that's complex enough to 1, max out system resources, or 2, herd productivity. As simple as that, right? So if you're in a situation where either your system's maxed out or your productivity is hurting because of the model, I would consider you in having a large assembly on your hands. Now, what are the symptoms that can cause these issues? There's a few, and that's going to help us troubleshoot, because solving large assembly isn't about doing one thing. It's oftentimes about doing a series of things. Now you have to know what to do. So slow performance is going to happen in different, you're going to have different symptoms. First of all, opening and saving times can be really long. Second of all, it could be performing rebuild. It could be moving, like doing a rotation, zoom, pan, rotate on the screen. Maybe that's what's hurting in your case. It could be things like moving components. It could be things like adding mates It could be things like making drawings. Now, a slow performance could be one or many of all of those. So that's why we have to understand where is the slowdown. That's going to help us troubleshoot and get better at it. So next thing I want to talk about is, what to do about it. Right now with technology, and SOLIDWORKS is doing a lot of effort to help that. But really, when you look at a large assembly, right now, there's about 30% is under SOLIDWORKS control, things we can do to the software to make it go faster. But at the end of the day, most of, enhancements you can put into making a large assembly go better is going to be under user control. So we're going to focus, especially for this half portion of our presentation, we're going to focus on user controls, right? So things you can do to make your assembly better, faster. So now that we've quickly defined what is a large assembly, let's talk about the activities that's going in SOLIDWORKS, what SOLIDWORKS is doing when it's opening and updating an assembly. That's really going to help us a lot when it comes down to looking at where to get our assembly better at, right? So if we look at this chart real quick, this chart right now shows the activities happening when SOLIDWORKS is opening a large assembly. So if we look at this a little bit closer, and I'm going to use the spotlight here. So first of all, we want to open an assembly. So once you're opening that assembly, what we're going to do is that, let's go back. Didn't want to go right there right now. So we open an assembly. Now SOLIDWORKS needs to load all the components, all the parts, could be thousands of parts. If you're lucky, there's no change that's happening to your assembly. So you're basically finished. It needs to paint the display here and then finish off, the operation. Now, in most cases, when there's a change to that, you're going to need to update the parts and sub-assemblies that are out of date. So that's going to take time. Then you're going to need to solve all the mates and all the position in your assembly, again, taking some time to do. After that, it needs to update the in-context features and assembly features. So for example, think a assembly pattern, right? Repetition, like a pattern, circular linear pattern, or an assembly feature like extruded cut at the assembly level, things like that. Now, once that is done, if there's any mates associated with that feature, that circle needs to start over again. So basically, again, think of it, this here can actually happen a few times, maybe a few hundred times in some assemblies where, you have to solve the mates, solve features, but there's actually parts in those features, so it has to solve back again. It might have to do that quite a few times. And then after that, it needs to go ahead and paint the display, continue to paint the display on the screen, and then you're finished. Now, the thing is, this is for an assembly. If you're opening a drawing, you have to do all of this on top of. And even if you don't have a assembly open, like you launch SOLIDWORKS and you say file open drawing, and if that happens to be an assembly drawing, it still has to do whatever the opening an assembly does. It just does it in the background. So for a drawing, you need to update all the configurations used in the views on that drawing. So again, so a lot more operation. Then, show the updated assembly in draft quality, solve the dependent views like section views. So if I have a view that's been modified, off of that view I've got a section, I have to solve the view first and then the section. So it's linear, right? So all of that, and there's operations being done in the background, but all of that can take quite a bit of time to do when you're opening assemblies, obviously. So, at the end of the day, there's a lot going on behind SOLIDWORKS simply opening assemblies, opening drawings. So you might, just by looking at this map, have a couple ideas of how to tackle some assembly update times and things like that. We're going to talk more, obviously, about those ideas, those tips and best practices along the way. So let's jump onto a big section we're going to talk about today: how to improve file open time. So you see that when you're opening assembly, there's a lot of things going on in the background. So let's take a look at how you can first troubleshoot, see where things are going and how SOLIDWORKS is opening these files, and see how we solve them. Now, actually, before I do that, I want to launch a quick poll. So I think I got a poll here. Yeah, let's launch this poll. So I'm going to ask you, what version of SOLIDWORKS are you using today? That's going to help me because some of the features are in SOLIDWORKS 18. Some of the features are enhanced in SOLIDWORKS 18, were there before, but made better today. So I want to have a quick overview of what version you're using today. So I can actually see some votes coming in right now. So actually a lot of people online today using 2018. So I did the same seminar about an hour ago in French, and most people were using 17. I see now that most of people here, actually half of the people here, using 18. So I'll give maybe a couple more seconds to wrap this up. So pretty much over, most of you have voted, so that's good. So let's just close the poll and let me share the results. So you see, like I said, over half of you today are using SOLIDWORKS 2018, which is great. I'm thrilled. A lot of you, about a third, I think, are still using SOLIDWORKS 2017. So I'll make the distinction. There are some new enhancements in 2018, weren't there in 2017. Things are there in 2017, just made better in 2018. So I'll try to, make the difference about that. So thanks for voting. So as I was saying, let's talk about file update time. So the first thing that is new in 2018 is a new assembly progress indicator. So this is, like I said, new in 2018. And when you open an assembly, you're going to see that little screen there. That's going to show you some good information. First of all, how many components you're opening and the progress of the opening of the file itself. It's going then to tell you what SOLIDWORKS is doing. So it needs to open, it needs to update, it needs to generate the graphics. It's actually showing you what SOLIDWORKS is, in which stage SOLIDWORKS is actually, what SOLIDWORKS is actually doing. The other thing that's kind of neat here is that it will show you the time, the elapsed time, so the time it's actually taking right now to open the assembly, and also showing you the time the last open took. So for very large assemblies, it might take a couple minutes. Well, you got probably that much amount of time to wait for the next for this to complete the open. Now, one thing I didn't mention here is that in 2018, you can also show in Windows Explorer a column showing the last open time and the last version saved as well. So that information, some of that information can also be brought directly into Windows Explorer, which is nice. The other thing too, if the dialog, if it opens, I believe it's more than 1 minute. After the file is open, the dialog will actually stay up, and you'll have a link there to start the performance evaluation. So to go directly into their tools performance evaluation. So from that screen, you can directly jump into it. I'm going to show that a little bit later. Another thing that we have in 2018, now it's been enhanced in 2018, is the assembly visualization. So the assembly visualization tool is in SOLIDWORKS, I believe, has been in there for like 6, 7, 8, maybe 8 release. So it's been there a while. But in 2018, we've made it more accessible, easier to get to. So in 2018, you can quickly create a assembly visualization and basically separate an assembly based on either the graphics triangle. Graphics triangle really relates to the graphic burden, how much, how big the display is. But you can also look at open times and rebuild times of components within your assembly. So this is a great tool to use. Like I said, it's available in 2018, it's enhanced in 2018, but it's still available in earlier release. It's just not as visible as it is in 2018. Also, let's take a look. So we have this assembly, and I'm going to, like you see here, open this assembly. So as it's opening, you see on the top here, that's the progress indicator. So you see how many parts it's opening, the progress of the open, the elapsed time. It's actually telling you last time it was open in 38 seconds. Generates updates and generates the assembly. So now my assembly is open. That's the new performance evaluation, was reworked in 2018 to give you a bit more information, better layout. So that tool existed, but now it's just made a lot better. The other thing too is that from here, we can use the assembly visualization to help filter out components that might be hard to display, long to open. When we do that, so the assembly visualization exists today. It's been there for a number of releases. It's just easier to get to. Now we can see we're actually filtering out by color using the parts and components that have the biggest display load or the graphic load. So here we have a part, we have another configuration, simple. As you can see, it turned blue because now it has a lot less display information it has to get on the screen. So the assembly visualization can be used different ways to filter out parts that have a lot of display entity to show, part that take a long to rebuild, and part that takes time to open. So you can filter out based on those criteria. Like you just saw, another method we want to use is use simplified version. So in the case here, we actually had a part with a simplified version. So at the top assembly, you want to use those simplified version. You might also want to use Speedpack. The idea with simplified version is that when you have a complex, a lot of complex cosmetic features, it will degrade not only assembly, but drawing performance as well. More to display, more time to display it, as basic as that. So one method we want to show or use is, at the part detail level, you might want to have the full detailed part for the part drawing, for example, the detailed drawing. But as you take this part, put it into an assembly, at the assembly level, we're going to, tell you that, using a simplified version is going to help you, not only in file open time, but also rebuild times in many cases. So when should we use a simplified version? So there's a few cases where simplified version makes just a ton of sense. For example, purchase parts. The thing with a purchase part is that, let's say, and we're going to actually see an example a little later with a gearbox. So let's say I have a gearbox. I purchase that gearbox. I go on web. I get a nice model. It has just a ton of detail, just a lot of information. And then I put that gearbox into my library, and I use that same gearbox in 15 different assemblies. Well, now those 15 different assemblies have to, make do with that extra burden, extra load. So especially for library parts that you purchase, oftentimes, these are some of the parts that you want to, target first for simplification. So for example, a roller bearing, you don't need to see the rollers and the bearing balls inside of the bearing itself. Just the general shape of the bearing will suffice. Too often still today, I see customers having, bolts, nuts, and washers, and they have like the threads, the helical threads, even have markings on parts. Now, it might make sense, again, for, like a casing to have some markings at the detail level, at the detailed drawing level. But when you use that into an assembly higher up, make away with that extra detail, threads and extruded text. Also, vents and fasteners. you know, if you have a part that has like a grill, for example, that has, you know, hundreds, maybe thousands of holes, there's actually ways in SOLIDWORKS to have a graphic display replace the actual physical hole pattern. And that's going to help you a lot, like you said, you know, in assemblies as well. So you want to be careful with that. Now, how do you first find, and second, make simplified versions of parts and sub-assemblies? So there's, first of all, we just saw the assembly visualization tool. So that's usually where I start. I use that tool just to target what makes sense for me to simplify. Once I've done that, you can use multiple tools. There's many different ways. Two tools I want to talk about today, the D-Feature tool and the Simplify utility. So let's take a look at both of these tools. First of all, the D-Feature tool. So with the D-Feature tool, let's take, for example, the gearbox, right? So I mentioned that earlier. And when I look into the gearbox, there's just so much detail. Now, I'm not interested in all of the bits and pieces. I just want to use my gearbox in my assembly. And notice as well that the gearbox has a gear ratio that I'd like to preserve in my assembly. So using the D-Feature, I'm going to simply search for the feature. If you want to look through the menu, it's in Tools, D-Feature. And launching the D-Feature will start this nice little wizard where I can simply say, hey, just go ahead and grab all parts smaller than 10% my assembly size. So that factor can easily take into account and gather all the hardware that you might want to remove. Another method is to simply say, first of all, select, and those are multiple choices. You can select multiples, but here I'm going to say, no, I'd rather just hide all the internal components first. So now it's grabbing all the internal components, things that we can't see from the outside. The other thing too is I want to preserve my motion. So I'm going to create groups of parts. So first of all, the casing with the bearing rings, that's going to be my first group. And notice underneath here, it's actually gathering the mates and moving the mates and keeping the mates into that motion group. Once I've done that, I also want to gather or keep certain features. Now, these mounting holes are going to be important in my assembly. That's where it needs to be bolted. Also, the internal tangency face, just as so I can gather the area I need for my mount when I'm going to mount this. Now, clicking on Next, SOLIDWORKS gets to work removing features, removing parts, and making a simplified version of this subassembly. Now, after a few seconds of work, SOLIDWORKS is going to show me the before-after. So to the left, you can obviously see the original model. If I do a section through it, to the right, you can see the preview of the simplified version. So, I mean, you can still see it's a gearbox, obviously. You can still see the mounting holes, the details is all there. And now the next step is that I can create a separate file with a link to the original. That's going to be important if I need to do some changes. I'm going to save my simplified version, overwrite the other one. And once it's saved, if we look at the simplified version, first of all, notice how less information is in the feature tree. Just 3 parts. I had probably 20 or 30 parts before with all the hardware. If I do a section through it, you'll notice that SOLIDWORKS went ahead and removed everything, all the internals, so making it a very simple component. But yet, I still have assembly motion because I created those groups before. So as I turn that shaft, the input-output shaft, the ratio of the gearbox is saved. Now, in the original assembly, I have an assembly feature. So if there's a change to any of the original components, I can always go back and update the simplified version. So this is a great way to simplify assemblies really quickly. Now, another way to do that, but at the part level, is use the Simplify utility. So you see here, another component of a transmission, there's a lot of features. When I look into that, it takes about 7 seconds to rebuild. 174 features, lots of detail. So using the simplify feature, or simplify utility, I should say, that can be found in Tools, Find, Modify, Simplify. Now this is going to act a little bit differently. It's going to actually look at the features. I give it a simplification factor, and I can do either, select features based on here, and I'm going to say, yeah, go ahead and find everything. And now it found actually 41 features that fit into that simplification factor. Now I could suppress manually, each of them manually. I'm going to instead say, yeah, suppress all of the small features, the small details. And very quickly, I get this part that can be saved as a derived configuration. So you see here, it's actually the same part, but now obviously the rebuild time dropped drastically, from 7 to about 1 second something. But this is a configuration. So if I want to go back to the original, fully modeled, fully detailed, there it is. But I still have my simplified configuration that I can either use at the assembly level or even at drawing level as well. So really a great way to simplify parts, and you can still see that the general shape is respected. It just looks pretty much the same without all the small details. So a great way to simplify these models using both of these tools. So we saw the D-feature tool. Another one is the simplify utility that you can use to do that. Now, the other thing that creates also a simplified version is a Speedpack at the assembly level. Now, what Speedpack does is that it reduces the amount of data in a subassembly to basically more or less geometry information. Also good for purchased components, also good for important assemblies. Oftentimes you have a big, model you have to import, might be a step file or something like that. The Speedpack doesn't care about features, so you could use that on a step file, for example, to make it just faster to open and to work with. And basically with Speedpack, what you do is that you define the face or the reference geometry you're going to need for mating. The rest becomes more or less like a shadow of the part itself. So a great way to simplify. The other thing, the other benefit that not a lot of people know of is that when you create a Speedpack configuration, you can send that file now, that assembly file, to anyone without sending any of the reference parts or assemblies. So another great way to just share information outside or even inside without having to drag the whole data set with it. So let's go ahead and take a look how to work on Speedpack. So here I got an assembly, as you can see, and I want to create a simplified version. So you see an assembly of about 200 parts. Not huge by any measure, I don't think, but still could be a good example to show how to create Speedpack assemblies. So from the configuration, I'm going to add a Speedpack. And the next is, again, a wizard base. So I'm going to say I want to either use the quick include, which will simply look at the assembly, and basically using a slider, you can decide how much information or how less information I want to keep in that Speedpack, or I can do manually. So for example, that body, that part is important. And for mating purposes, I'm going to need this face and those 4 holes, because I know that's where I'm going to mount them into my top level assembly. So as I do that, and now I hover over the part, you'll notice that around my cursor, only the elements I've selected as reference are shown, and very little is actually saved in the part itself. So it's at the configuration level that we act and we do that. So if I open the top level assembly, and you'll notice that this top level assembly opens really quick because all the sub-assemblies are Speedpacked. So first of all, the open time, you save a lot right then and there. I'm going to insert this new Speedpacked assembly. As I insert it, I want to mate it, but because I've selected those faces as reference earlier, I can reuse those for mating purposes. Also, really a great way because it simplifies the work of doing the mates at the assembly level. So if I want to, I know that only these holes should be used for assembly. I can use Speedpack as a method to simplify the mating or the assembly purpose, the assembly setup over here. So setting the holes at being concentric, and if I want to get rid of that kind of hole, that you can also disable that as well. The Speedpack circle, we call it. Now, because you create a Speedpack doesn't mean you can't do anything else after that. So even with a Speedpack assembly, although limited, you can still do drawing operation. So for example, I could grab my views, and then drop the views here, top, front, top, left. I'm going to draw a isometric view as well. So I'm going to drop this over here. I can add some colors. And because this is a Speedpack assembly, this is still very lightweight, even at the drawing level. So over here, I'm going to add a bill of material. So again, we can do that with all the information coming in from my assemblies. So that's very easy to do. And like I said, although we're limited to do those views in some regards, you can still use them to create add dimensions. So I'm going to add a few dimensions just to kind of work as if I was working in that assembly. So you see that even with Speedpack, you can still quite do some work at the drawing level, but that's going to help you a lot at the assembly level as well. So next thing I want to talk about is working locally. So that's also a big component. And why is that important to work locally? So I'll get a little animation here just to explain what happens when you work locally versus opening files from a network. So if I work locally and I'm on my computer, I do file open, well, the file is on my computer, it's easy to get to, SOLIDWORKS can open it quite quickly. Now on the opposite hand, if I'm working from a network, that operation is quite different. First of all, if I'm opening from a network, I'm gonna inside SOLIDWORKS say file open, but I need to go on the, let's say, Z drive, for example. So what's going to happen is that SOLIDWORKS needs to get to first access my network. From the network needs to access the server and tell the server to, hey, go and find and spin the drive to find the file that's on the drive somewhere. So as you can see, there's a lot of things that need to happen and a lot of things that are not dependent on SOLIDWORKS. SOLIDWORKS doesn't control the speed of your network, doesn't control the load on your server, doesn't control the speed of the server drives. But if everything's local, you got much better handle on these things. Now, the other thing too is that, let's say SOLIDWORKS needs to open a file. SOLIDWORKS cannot open the file as a whole through the network. It needs to break it down into chunks and move those chunks through the network one by one. And that's actually the Windows infrastructure that's built like that, the architectural Windows itself. There's nothing we can do about it at SOLIDWORKS. It's just the way Windows works when we open files. So all those bits and pieces need to come back across one by one across the network so that it can be kind of stitched together inside of SOLIDWORKS. And, also on the back end, if you take a file and you simply copy it locally, Windows can take the whole file and copy it as a whole. But if you open that same file through a network, SOLIDWORKS can only open bits of that file at a time. So that's going to add a lot of time because you're going for all those bits and pieces, they all have to go through that process. So here's an example. In this video, we're showing opening locally on the left, opening on the network on the right. And although when I do file open on the network on the right, the preview comes in quite quickly, look at the left. We're already done loading this assembly. While on the network, SOLIDWORKS is still fetching files, if you want, through the network and opening these files. So you see here, it's not a big assembly. It's a minute versus 15 seconds, but you can see there's like 4x difference right there. Now, I also did a test. Now, I have to be transparent. I don't have a full server installation. I work from my home office, but I do have a external drive. So I did the test, and actually I did the test with PDM. So I opened up this assembly inside of PDM, and I look at the progress indicator. And inside of PDM, when I do in PDM file open, it takes me 35 seconds to open. That includes making a copy on my local cache. Now, I'm going to talk a little bit more about that. Now, if I took the same data set that was open, I copied it on my Z drive, and then I did a file open directly from the Z drive, and you can see a huge difference, obviously. Now, again, I want to be transparent. I don't actually have a server. You know, I just use a Z drive that's connected to my router, but that's actually one less thing in between the data and my computer if I look at my network. But you can see that there's a huge time difference just there. Now, like I said earlier, PDM is going to be a big part of that, because what PDM does in the background is that even though you're on a network and your PDM is installed on a server, when you say file open in PDM, it's actually going to make a local copy. So it's going to take all the data, copy it locally, and then open it in SOLIDWORKS. While it's making that copy and opening, it's still faster to do that than to open across the network. Like I said, I mean, we have the, I have some more information on that if you're interested, but just the ways of the Windows architecture is built, it's actually faster to copy the files first locally and then open files than to open directly from the network. So our PDM does that, PDM Standard, PDM Professional. If you're using another PDM or looking at another PDM, make sure that it works with a local cache system, because if it doesn't, your PDM is not going to help you. So you want to make sure of that. So another method we want to use to help large assemblies is to use the large assembly mode or lightweight mode. Now, there's a subtle difference between the two, so let's explain that. So when we use lightweight mode, the idea with lightweight is that when you open assemblies, you load less data into SOLIDWORKS, into memory, into the system. So a lightweight part actually loads less than half the data as if you were opening something fully resolved. So when you open something in lightweight, there's no features that is loaded into the system, only the body information, so the geometry of the part, also the mates. Obviously, you want the mates for assembly motion, but since you're loading body, you can still add mates. You got the information, you got the faces and all that information. So you have the information there to create new mates and to continue your work, but you're gonna have motion on top of that with the mates, of course, but with a lot less data. The other thing too is the large assembly mode. Now, the large assembly mode will use lightweight. If you look at the default options and you didn't change any of the default options, when you use large assembly mode will leverage lightweight, but it will also toggle a few different settings on top of using lightweight. So display settings, rebuild settings, and things like that. So large assembly mode goes a little bit further than lightweight, as it is using lightweight, but doing a couple other tweaks on the background to give you better performance as well. The other one I want to talk about is large design review. A few people use this tool, unfortunately, but it's a great tool. what large design review does, it's actually it's even less data than lightweight. There's even less information than lightweight that it's using when you're opening something in large design review mode. It only uses display data. So not even the mate information, not even the full geometry, just the display, the 3D display information. Now in LDR, you can't do everything you do in large assembly mode or in lightweight, but you can still do quite a bit. So you can use your measuring tool, you can do walkthrough, you can do snapshots as well, and I'll show that. But it's also a great tool to simply isolate and strategically load what you actually need to work on. You know, when I have a large assembly, I know what the top level assembly is, and I know I need to do some changes in maybe some of the few sub-assemblies. So I can open in large design review mode to get the overall picture of my assembly, and then simply go ahead and pick the sub-assembly I need to work on and open that. Let's actually show that real quick. So in this example, I have a really large assembly. When I go in my recent component, you can see here I got the option to open in large design review, and you might have a sense of the size of this assembly. This is about 6,000 components, I believe. But even though, as I do that really quickly, a matter of seconds, the file's there. The full 3D model is visible. I can zoom, pan, rotate. You can see it's fairly smooth. I can even change the display. I like to have my edges shown. But even like, pan, zoom, rotate, you see it's very smooth. So as I work through that, I can actually see a lot of detail into that top level assembly. Now, a couple of things you can do in large design review is create and play walkthroughs. So if you want to immerse yourself into the assembly, the design, you can actually create trajectories and walk a camera along those trajectories and just view that information. You could even from here save that as a video file if you wanted to. So a great way to immerse yourself into the assembly. Another thing you can use large design review mode is as the reviewing tool or a markup tool. So here we got snapshots. Basically, snapshots are saved camera views. Saved camera views that can also be complemented with text information, right? So I've got a note here, a comment that says to check the clearance between the valve and the housing to make sure we have room for maintenance. To that, I could add a date stamp, add images, even a screenshot. But here's where it gets really interesting. I can create a section view, and did you see how quick that was? It's a large assembly, and really quickly I was able to create that section view. I can use the measuring tool, so I want to measure the gap between the head of the bolt here, because I think that's going to be an issue in my assembly, and the back of the pump here, or the valve. And I can see that the distance is not even 3/4 of an inch. Obviously, I don't have enough room here to change the bolt if I need to change this part. So as I go back and disable my section view, I'm going to look into the assembly. And as you can see, you got the full assembly feature. I select a part, it cross highlights in the tree. And from the tree, I could simply say, yeah, that subassembly needs to change. I'm going to right click and open it. So as I said earlier, this is a great tool to just get to where you need to go without having to browse, countless files in your Windows Explorer. So I can open the top level assembly, find my subassembly, go in, open it, change it. So I'm going to give some more thickness here to get some more clearance out of that back plate. Then I'm going to save it. Now, SOLIDWORKS is going to ask me, you want to update the large design review mode? I'm going to say yes. So as it's saving here, it's also updating the graphics on the large design review mode on the back end. Going back to the large design review mode, I see that I now have the updated graphics over here, so I can continue my work using, at the top assembly level if I need to, and maybe find another sub-assembly I need to change. So that's a great way as well to work on large assemblies. You can use the large assembly mode, the large design review, just to find what you need, and then drill down the assembly tree, open up, and continue working. Now, another thing I want to talk about is display states and configurations. There's a lot of confusions out there between why should I use a display state versus why should I use a configuration, and what's better, what's the other one. A general rule when we talk about large assembly is use display state when you can. When you can't, use configuration. So use display states instead of configurations whenever you can. So let's talk about this and describe this a little bit better. First of all, so we got configurations, we got display states. What makes one better than the other? So you want to use configurations to show a different design, right? This design is round, this design is square. Is a square, is a rectangle, is a triangle, different design. You want to use display state as it says to show different display. So if it's just visual you want to control, you should use display state. And by that I mean color, I mean show hidden, transparency, even hidden line remove, hidden line visible, shaded with edges, shaded without edges. Those are all display controlled, right? So you can all control that using display state. Let's dig a little further. When you create a configuration, you're creating basically a new assembly inside the current assembly, a new assembly or a new part, right? So configurations can be used for both assemblies and parts. Same for display state, by the way. So whereas a display state, you're basically just putting a skin on top of the existing assembly or part. So what that boils down to is that configuration contains a lot more data itself, a new configuration, than a display state does. So there's a lot more information in a configuration that there is in a display state. Also, when you change between configurations, oftentimes you will need a rebuild because the data is very different. Changing between display states does not require a rebuild. So at the assembly level, if you're just controlling the visibility of some components, the color of some components, you have to use a display state to do that. Because, like I said, when you change from display state to the display state, you're not rebuilding. When you're changing configurations, most of the times you are. So also benefits with display states and drawing. So I'll talk a bit more about that later. The other thing that you want to do is convert your data forward to the latest version of SOLIDWORKS. So you know that if you've been using SOLIDWORKS for multiple release, that when you change your release, so you were using SOLIDWORKS 2017 and now you move to SOLIDWORKS 2018, well, you have to convert the file to the 2018 format. Now, the conversion, what's important to understand is that the conversion happens on file open. So if I open a file that's not been converted, I just open it and I close it and I don't save it, the next time I'm going to open it, it's going to do the conversion again up until I save it to the latest format. So you have to understand that. So as you're working, try to move your data to the latest release. Now, there's a exception to that. If you're working on 2018 and some of your team members are working on 2017, the last Service Pack 5 of 2017 can actually open 2018 files without having to convert. So sometimes you might be caught a little with one release behind, or you're working with other team members, they're using for their project the latest release, you have the release right before. Well, just so you know, you can actually use Service Pack 5, so it has to be Service Pack 5, so you can open data in the future version of it. Now, there's tools also to automate that, the conversion process. If you just open something and save it, it's going to convert it once it's saved. But if you don't want to have to do that manually, you can also use two tools. There's actually the task scheduler. If you have SOLIDWORKS Pro Premium, there's a task scheduler you can use to automate that process. You can even distribute the conversion process into multiple computers. If you're using PDM, either PDM Standard or PDM Professional, you can use the PDM file upgrade tool as well to do that. So it's going to go in the vault, might create another version or revision of the file as it's doing the conversion. So you're keeping the history as well. So we talked a lot of things. So we're already close to that hour mark. So I told you there was a lot of content. That's why we decided to split in half. But what did we see to improve file open time? So first of all, use the assembly open progress indicator, new in 2018, to just see how the progress is going. Use the assembly visualization tool to help you troubleshoot what files are taking the most time to open, what file are creating a lot of burden on the graphics, etc. Now, the assembly visualization exists before 2018 as well. So if you're on an earlier release, you can still use it. It's a bit more, it's not as easy to discover, but it is there. Also use simplified version, either through configurations. Speedpack is another method of using creating a simplified version of an assembly. Work locally, and I put PDM in there. Not to brag about our PDM, we have PDM Standard, we have PDM Professional. Both of our PDM systems create a local copy when you're working on something. Now, if you're looking into another PDM system, make sure that it does the same thing. It has that local cache process of opening files. If it doesn't, you're not going to see benefits on large assemblies using your PDM system. So make sure that your PDM system works locally on the local cache. Next, we talked about large assembly and lightweight mode. So both of these can help, improve your file open time as they're loading a lot less data into memory. The large design review can also be used to improve that, especially to just, find what you need to work on, right? So you can use the large design review to do that very quickly. We talked about display state. My rule of thumb is, use a display state up until you can't. Also benefits in drawings as well. So in a drawing, if you have multiple views that link to multiple configurations on the back end, SOLIDWORKS needs to open all of those configurations. That's not doing it with display state. So display states can also be repurposed, reused into drawings as well, pretty much the same way configurations can. So there's benefit in drawings as well. And also convert data to the latest release, as much as possible. So that kind of wraps our session for today. So I'm going to take a quick peek about the questions I do have. Okay, so good question. So some people at my company argument that when handling large assemblies, features like cosmetic thread and consume a lot of resources, so they should be suppressed. Everything you can suppress will help. Cosmetic thread is still better than the actual physical thread, right? So as far as performance goes. So yeah, if you can suppress it, cosmetic thread to some level might not affect that much. You need to kind of investigate a little bit further if that's really the case. But yes, it can give some burden. It's going to be mostly graphic burden though. So a cosmetic thread, a bolt with a cosmetic thread, should not take longer to open or to save than one without. But graphically on the screen, zoom, pan, rotate, yeah, it can affect. So again, what is the issue? We have to kind of find that issue. Is it the open? Is it the graphics? So there's quite a few things. There's a few questions today. So I'll try to open as much as to answer as much as I can. So the open time function on PC, that's also a good question. So the open time will tell you the time it took to open on a set machine. So if you have two distinctive machine, one is a really low-end computer, one is a really high-end computer, yeah, I mean, the open time might be a little misleading, so you have to be careful of that. But if you have a set of computers that are mostly the same, the open time is going to be similar. So that's a good question as well. Wow, lots of good questions today. Can an assembly set to automatically select simplified versions of components or sub-assembly if they exist? Good question, yes. When you go in File Open, you got an option to get some more information. And if you set your standards to have a configuration called Simplified, you can actually say, SOLIDWORKS, open this assembly, but always use the simplified configuration of any of my components if they exist. So that's a great way to open up a simplified version of an assembly. Wow, there's a lot of questions. Like I said, I might have to follow up. Oh, if there's a training course. So we don't have training course per se on large assemblies. We used to have a book. I'm actually inquiring to our training department if we're planning on upgrading this. Really, the best method, I would simply get in touch with your reseller. Most of them already have some training available, or they can actually go in. Some of them also do assessments. So that's also a great way. Have an expert in for maybe a few hours to look at your large assemblies, and with experience, what our VAR application engineers have, they can actually find information quite quickly. So I would say, ping your reseller. They can definitely help with that. So good. I think I'm going to wrap it up. Again, I'm looking at the time. We're already at our hour mark. So just last words to wrap up. Just as you know, we're recording this, obviously. So the recording will be available shortly, probably by the end of the day. That's actually if you screen grab this with your phone, that's a QR code. You can land directly on the page. If you don't have your phone handy or can't really, the address is a bit long. But if you want to have the link to the web page, I'm going to give you my email address, plus Joel. So Joel, that you heard did the opening, the introduction. So that's our contact info. For any questions, so I'll try to answer the questions that I couldn't do live. So I'll do that offline via email. So might go early next week before I can get to it. But the recording is going to be there, going to be available to anyone. Here's our contact info. If you have some more questions and you want to ask, just shoot me an email. And you'll also receive tomorrow, I believe, a follow-up email with the link to the recording. So if you can wait until tomorrow, you're going to get the link anyhow in a follow-up email. So I will say this. Thank you, everyone, for joining. It's a lot of information in an hour. I realize that. And we're going to follow up, like I said, with another session a little later on. So thanks again, everyone. And I hope to see you soon. Thank you.